So one of the things that we can do here is that we can calculate the weight of the water bottle. So a lot of times we don't understand what we mean by weight. This is what we mean by weight. So we can calculate the weight of the water bottle. And what we're going to do here is that the way we do this here is that we have to start off with N2L. And what N2L tells us is that the acceleration is equal to the net force divided by the mass, or I can write this as the net force is equal to mass times acceleration. And this is probably the most common way that people write it. So we're going to use that. So if mass, which we define as m, is equal to 1 kilogram, and the acceleration due to gravity, which is 10 meters per second every 1 second, that's what we call g, then that tells me here that the weight of the water bottle is then going to be the force of gravity times mass times acceleration. But the mass is 1 and acceleration due to gravity is 10. So then the water bottle weighs 10 newtons. So this tells me here that to be balanced, the force of the hand, which is of course the force of gravity, that means that my hand has to hold up, has to apply a 10 Newton force. And so what I want to do here is that to give you a sense of how we use this all the time, one of the things that I want to do here is that I want to come in and I want to look at something that you see a lot are hanging pictures. So when one hangs a picture, frame on the wall, there are two possible ways to do this. So one way that you can imagine here, so let's imagine that we have something like this here. So let's draw a picture frame. So let's say this is a picture frame. And for the sake of argument, you are in love with your car. So I look at this picture frame. And then you take a picture of your car. And because you love the baby blue color, you hang it on your wall. Well, what I want to do here is that I want to copy this. And the one thing I want to pay attention to is what I'm saying here is that there's two ways that you could hang this thing. One way that you can do it is that in each situation, we typically see one nail. Okay, so this thing here could be, let's say it's a nail or a wall nail or some sort. Now, what you can do here is that you could take this thing and you could actually hang it by one wire versus two wires. And what you find here is that I'm going to make an assumption here. We're going to assume the weight of the picture frame is the force of gravity of 10 newtons. Since we're using 10, we're going to continue to do 10. The question is this: you never see this, and you always see this way of hanging a picture. So the question is, why? I mean, the one on the left, you could totally do that. That would work just fine. But the one on the right is the most common way. So, and what I would say is that there's two reasons why. So there are two reasons why the right setup is always used. And what I'm saying is that, one, it's easier to balance. And what I mean by balance here is that you can, it's easy, maybe balance is a bad word here. It's easier to adjust the frame. And the second one, believe it or not, it's about strength. And what we want to talk about, strength. Why do they set it up this way? Because of strength. So one, it's easy to adjust the frame so that you can, make sure that it's nice and clean here. Or, it's hanging straight. So now, here we go. So we want to answer the second question. And the question is, picture frame is at rest. It's at rest in both situations. We don't want picture frames to be moving. So therefore, its acceleration is 0. Therefore, the net force is 0. And as we already know, there has to be what? There has to be balanced forces. Now, suppose, furthermore, that the wire that holds up the picture can only, no, maybe I shouldn't say it that way. Holds up the picture, suppose that the wire that holds up the picture has a maximum or maxima, no maximum, of 8 pounds. And note that all of your wiring, including typically how the nail goes into the drywall, comes with the calibrated strength that people talk about. So let's go look at that. So here is our picture frame right here. And what we'll do here is that we'll say this guy here is going to be our first case number 1. So you have a single wire. So when I have a single wire like this, what really happens here? Well, here's the nail, and then here's our little wire. So when you look at this thing, look what happens. When I look at this, our picture frame weighs what? It weighs 10 pounds. So the weight of the picture frame is 10 pounds. Oh, I said 10 newtons. Let me be careful. I'm using wrong units. Up here, I said 8 pounds. I should have said 8 newtons. So that's a mistake here. Okay, 8 newtons, not pounds. So then what you're finding here is that the strength of the wire now is not the same length, it's less. So the strength of the wire is 8 newtons. So that immediately tells you here that this wire frame will never hold up the picture and the wire snaps and the picture falls. Now I could get a wire that it can handle more strength, but note that that costs more money. And typically companies want to save money. Now let's look at this thing again. Now you might be saying here, so in this case here, I'm going to say that even though you do attach a single wire in the second case's situation, it acts like 2 wires. Believe it or not, it acts like 2 wires. So what that means here, one of these is a blue wire and the other one is a, let's say it's a red wire. And I'm going to call the red one wire number 2, and I'm going to call the blue one wire number 1. So a single wire over a single nail, right? So a single wire over a single nail acts as 2 single wires. They literally act like 2 single wires. So what you're going to find in this case here, so I'm going to move this up just a little bit higher, is that this is what happens here. So if I come in and I put my picture frame here again, what that means here is that this is what happens here. What I see here is that the number 1 wire acts separately from the red wire now, because now it's not 1 wire like up above acting on this, right? This is 1 connection here. What you're seeing here is that there are now 2 connections here, and that's force number 2. And we still have the same force of gravity acting downwards. And we know that that is 10 newtons. So if I was to redraw this picture here, here's what happens here. I know that this thing is at rest. And I know that the force of gravity in this situation is what? Let's say is 2 squares. So this is the force of gravity of 10 newtons. So if there's 2 squares, that means that the only way is that if I have a balanced picture frame, what you're seeing here is that 1 square is the force of 1. 1 square is the force of 2. And what you're seeing here is that according to Newton's second law, the only way this could be true here is that if I have balanced forces. So what this tells us here is that force 1 is equal to force 2, and that has to equal 5 newtons. So all of a sudden, what you're seeing here is that this so what this implies here that a 8 Newton strength wire can hold up a 10 Newton weight picture frame, which is pretty cool. So by doing this, it costs less money. And that's why having a wire attached 2 different places on a picture frame will give you that scenario here.